Good morning, Precal. Or at least it's morning now. It may be afternoon when you're watching. But anyway, hi. How's everybody doing today? Everybody's having a fantastic day. It's going to be a relatively short lesson today. We're talking about maximums, minimums, and just some other random transformations. Yesterday we talked about transformations. Today in class we're working with transformations some more, talking about shifting things up, down, left, right, making horizontal shrinks, vertical shrinks, vertical expansions, horizontal expansions, all that jazz. So today we're going to get into more of the max and min. Now everything we've been doing has been to identify certain parts of functions, right? Everything we've been doing has all been about learning to identify and picking information out of certain functions. So I have a function drawn up here for you, and very easily give the interval where the function of f is increasing and decreasing. Okay, so there seemed to be a lot of confusion on this earlier, so I want to take a chance to clarify it. When you see the word interval, you need to write it as an interval. I'm not asking for a point where it's increasing or a point where it's decreasing, but an interval from where to where is this increasing. So here's what I'm going to do. I'm going to take my little finger here and I'm going to point to where it is increasing. So as you approach this question, where is f increasing? Well, it's increasing here. And where else is f increasing? Well, it's increasing here as well. So let's write the interval for this guy at first. Intervals go from left to right. We always read a graph like we read a book, from left to right. So how far left does this piece of the graph go? Well, it goes left to negative infinity. This thing is going to keep going left. So negative infinity, obviously we can't touch that. And where does it stop increasing? Where is the hilltop? Well, that happens at -2, right here. So it's -2. Now we can't actually touch -2 because once you're on top of the mountain, you're no longer increasing. You're pretty much flat even, right? So we're not going to include it. And then we can start up again. Where does it start going uphill again? Right here at 3. Not touching 3, but right there at 3. And then going up there to infinity. Or going over there, I'm sorry, not up there, but going over there to positive infinity. It's going to keep going right. And so it's only decreasing in one spot. Where is it decreasing? Right here. What's the interval for this section of line? Well, it goes from here to here. What are those values? From -2 to 3. All right. So a couple things here. Since f is increasing to the left of x equals -2 and decreasing to the right of x equals -2, f has a maximum at x equals -2. Basically what it's saying is if you're walking uphill and then you went downhill, then you start going downhill, at some point you had to reach the top of the mountain, right? So the maximum of f at x equals -2, go to -2, find your maximum, is 4. So if you start walking uphill and then all of a sudden you're walking downhill, at some point you had to reach a maximum. You had to reach a highest point. Otherwise you would not have turned downhill, you would still be going uphill. Then since f is decreasing here to the left of 3 and increasing to the right of 3, so since you're going downhill here and uphill here, you can't go downhill then uphill without hitting a low point. We have a minimum at x equals 3, and the value of that minimum right here is 0. Max and mins are very, very simple to identify. They're the mountaintops and the valleys, the very top of the mountain or the very top of the graph. If we want to use proper terms, it's the highest point on the graph. It's the highest value for the graph at a given point, or on a given interval, right? So let's go down here. It says the figure below shows the graph of f of x. At what values, if any, does f have a maximum? So where does it have a maximum? Well, it's got a mountaintop here, and it's got a mountaintop here. So at what values does it have a maximum? Notice it is not asking me what the maximum is. It says at what values. This is kind of like asking where does f have a maximum? And you know that when we see the word where, I want x values. So that is at x is equal to -7 and x is equal to +7. It's like saying where. Now, if you actually gave me the answer, that would be what is the value. So at what values is kind of saying like where. You know, at what point in this road trip are we going to stop? That's asking where. Where is this going to happen? And then the value of the maxima, the value is what? What are the maxima? That is the value. What is the maximum points? Maxima here being the plural of that. What are the maxima? Well, in this case, they're both 3. Both of these have a y value of 3. All right. And justify your answer. Think about this. These are maxima. So I'm going to state what I have right up here. What I just put for maximum up here, that's what they're wanting me to state. Anytime you see the word justify, they are wanting you to use a definition of something and tell me why that's the case. So justify your answer. So what I'm going to write, f is increasing to the left of x is equal to -7 and 7, and f is decreasing to the right of x is equal to -7 and 7. That is a justification. It's a maximum. How do you know? Because it's going up on the left and down on the right. That's what a maximum is. At what values, if any, does f have a minimum? Remember, this is asking where. Where does f have a minimum? Well, it's got a minimum right here. All right, so where does that happen? That happens at x equals 0. Right? What is the minimum? -4, the y value. Alright, so what's the domain of this function? Unless I actually put an endpoint on this and you can see very clearly that this thing ends, we assume it goes on forever. Especially if it goes down here and touches the edges of the graph. Oh, it goes on forever. So what's your domain? -infinity to +infinity is what it looks like to me. Or we could just simply say all real numbers. Is it even, odd, or neither? Well, what kind of symmetry does it have? Does it have an x-axis symmetry? No. Does it have an origin symmetry? Meaning if you flip it upside down, do you get the same thing you started with? No. Does it have a y-axis symmetry? Yes. And that means it's even. This y-axis cuts it smack in half, perfectly even on the left and the right. It's like a mirror. And the range, how far down does it go? Well, we said earlier it's going to keep going forever, so it's going to go down to -infinity. How high up does it go? Well, it goes up to 3. Does it touch 3? Sure looks like it to me. We just said it did right here. So I'm going to put a bracket around 3. Alright? So just a little bit on transformations here. Again, if you need to pause to take time to slow down, please feel free to do so. All right, so a little bit more on transformations, just very quickly here. If 5, -1 is a point on f of x, what will be the corresponding point on the following transformations? 5, -1 is a point. What's going on here with 3f of x? What are we doing? 3 and f of x. Remember, f of x is y, right? So aren't we just multiplying our y value times 3? So wouldn't that point then be 5, comma, you take 3 times your negative 1? 5, comma, 3 times your negative 1. And that's what? That's 5, negative 3. Just like that. What if you do this in here? F of x plus 4, this is in parentheses, so we always do the opposite of what's in parentheses. Always do the opposite of what's in parentheses. Alright, so you take your point here, 5, and you're going to subtract 4 from it. Now what that does is move your graph left 4. So what's that point? 5 minus 4 is 1, comma, negative 1. Always do the opposite of what's inside the parentheses. And then you get to C. Well, what's happening on C? On C, we've got a 2x, so that tells me I'm going to be doing something with my x values here. Since I do the opposite, what am I doing to x? I'm going to be dividing by 2. So here's what I'm going to do. I'm going to write this down here. X comma y. My x values, I'm dividing by 2. Now my y values. Now this is something interesting because if you look at the negative placement right here, I've got a negative value in front of f. And then I've got this positive 3 right here. Isn't this the same thing as saying negative f of 2x plus 3? If you switch the order of those. So what is this going to do? The negative is going to change the value of the y. And then I've got a positive 3. So I'm going to do it like this. Negative my y value plus 3. Well, what's your y value? It's negative 1. All right, so let's simplify. 5 halves, comma, negative negative 1 is positive 1 plus 3, 4. There we have it. All right. So if it helps to switch the order of these, I really think it does. I would do that because to me it's very easy to see here that this is a plus 3 and that you are making the f negative first. Remember, always do your reflections first. 3, given the information on the graph, given the graph of f of x at the right, graph and write the equation for each transformation of f of x. Alright? So the first thing I'm going to do is pull out these points. Looks like we got negative 8, negative 4, 0, 4, 4, negative 2, and 8, negative 2. And then it says the domain of the transformation is negative 4 to 4 and the range is negative 6 to 2 with an x-axis reflection. Holy moly! First off, up here, what's the domain you see up here? It goes from negative 8 to 8, right? That's a 16 unit span. That's 16 units long. What's your range? It goes from negative 4 to positive 4. That's 8 units, right? It's 8 units tall and 16 units wide. Okay? So for A, it says the domain of the transformation is negative 4 to 4. Hang on, the domain is negative 4 to 4. How big is that? Negative 4 to 4 is only 8 units. Alright, negative 6 to 2. The range is negative 6 to 2. That's 8 units. So the range has stayed the same, but it has moved a bit. Stayed the same size, but it's moved a bit. So let's write some of this stuff down. Always start with your x-axis reflection. Right, x-axis reflection. That means that your y's are going to become negative. Okay, very important here.